Hello, everyone. Today, let's study the vision. Where this PowerPoint, we can see there are some test slides. However, so we can skip this now. So here we are. So let's talk about the eyes and the vision. Okay. So first of all, let's talk about the extra eye muscle. Okay, extra eye muscles. So those small muscles actually attached to the eyeball to regulate the eyeball movement. Okay. So here we can see. So if we so now let's take a look at the figure A first. Okay. So we can see. So let me take a pen. So if let's take a look at the superior muscle. Okay, so we can see this one. So this is the superior oblique muscle. Okay, superior oblique muscle. Superior oblique muscle actually can cause intorsion. Okay, intorsion. So intorsion is the primary action of the superior oblique muscle. Okay, it can cause eyeball intorsion. So its secondary action, secondary function is to cause eyeball depression and abduction. Okay, so the depression and abduction is the secondary function of the superior oblique muscle. Okay, so if we look at the so the superior oblique, so why is it called oblique muscle? So we can see this muscle. So here is the chocolate. Okay, so here is the chocolate. So this muscle actually attached to the chocolate, and then so the muscle have almost almost so the muscle have more than 90 degree and have more than 90 degree deviation and then attached to the eyeball. Okay, so it's like this. Okay, it's like this. So that's why it's called oblique muscle. Okay. Uh, so here, so this one is the superior oblique tendon. So the tendon actually is tendon is dense connective tissue that connects the superior oblique muscle and the eyeball. Okay, so so this is called the oblique tendon. Okay. Now let's look at this muscle. Okay, this muscle is called the superior because they are on the top, or they are on the uh, upper part of the eye. Okay, so this is called the superior rectus muscle. Okay, superior rectus muscle. Superior rectus muscle, we can see it attached to the upper part of the eyeball. So once this muscle contracts, it can cause the eyeball elevation. Okay, eyeball elevation. So this is so elevation is the primary function of the superior rectus muscle. However, it can also cause the eyeball adduction and intorsion. Okay, because we can see because it's attached to the lateral upper part of the eyeball. Okay. Now let's take a look at the third muscle. Is this one? Okay, this one. This is called a lateral rectus muscle. Lateral rectus muscle, because this muscle attached to the lateral part of the eyeball. Okay, so the lateral rectus muscle has only one function. So this primary function is abduction. Okay, abduction. Now let's take a look at this one. Okay, this one. So this is inferior oblique muscle. Okay, inferior oblique muscle. Inferior oblique muscle. So we can see. So this muscle actually attached to the lateral part of the eyeball and surround the eyeball and then attached to the bone. Okay, so the inferior oblique muscle's function is to induce the extorsion. Okay, extorsion. So extorsion is his primary function. And so once this muscle contracted, it can also cause eyeball elevation and abduction. Okay, elevation and abduction. Now let's look at this one. Okay, this one. This is the inferior rectus muscle. Inferior rectus muscle. So the inferior rectus muscle, since it attached to the lower part of the eyeball. Okay, so once this muscle contracts, it can cause the eyeball depression. Okay, eyeball depression. So it can let us look downwards. Okay, so this muscle, so the depression is the primary action of this muscle. However, this muscle can also induce the abduction. It can induce adduction and extorsion. Okay. So now, so we cover. So we have another muscle. So this is the medial rectus muscle. Okay, medial rectus muscle is this one. Okay, medial rectus muscle. It's this part. Okay, it's this part. So it's medial rectus muscle. So based on this term, we can know that this muscle actually attached to the medial part of the eyeball. So once this muscle contracts, it can cause the eyeball adduction. Okay, adduction. So that means so it can induce so it can allow us to look at the nasal part of our head. Okay, so this is can cause the adduction. However, so this is the only function of this muscle. Okay, so this muscle doesn't have the secondary action. So we can see, so this one is the optic nerve. Okay, optic nerve. So the optic nerve attached to the eyeball. Okay, so we can see, so this is trochlear. Okay, trochlear. So the superior oblique muscle actually attach the eyeball through the trochlear. Okay, through the trochlear. So this is superior oblique tendon. So these muscles actually are innervated by the cranial nerve. Okay, by the cranial nerve. So we can see the lateral rectus muscle. This muscle is innervated by the abducens nerve. So this is sixth cranial nerve. Okay, sixth cranial nerve. So because the lateral rectus induce abduction, right? Abduction. So that's why it is innervated by the abducens nerve. Okay. So the medial rectus muscle is induced. So it's innervated by the oculomotor cranial nerve. This is a 3. Okay, 3. Superior, inferior rectus muscle so actually are also innervated by the oculomotor nerve. Okay, so the oblique muscle, superior oblique muscle, is innervated by the trochlear nerve. Okay, trochlear nerve is 4. Because this one, so this muscle actually attached to the eyeballs through the trochlear. Okay, so that's why it is innervated by the trochlear nerve. Okay, so the inferior oblique muscle actually is innervated by the oculomotor nerve. This is a 3. Okay, so that means we can see all the extra eye muscle are innervated by the 3, 4, 6. Okay, 3, 4, 6. So now let's take a look at the eyeball. Okay, the eyeball. So the eyeball. So the structure of eyeball. Okay, structure of eyeball. So the structure of eyeball. So if we take a part of take a part of the eyeball. Okay, the wall of the eyeball. So we can see the eyeball. So the wall of the eyeball is consists of the three layers. Okay, three layers. So the layer of the eyeball is called tunica. Okay, tunic. Okay, so the three tunica. So these three tunicas are fibrous tunic, vascular tunic, and sensory tunic. Okay, so the most tunica is the fibrous tunic is this one. Okay, so the fibrous tunica is consists of two parts. The first is the scleral. Okay, this one is the scleral. Okay, this one is scleral. So the second part is the cornea. Okay, cornea. So the scleral and the cornea actually they made of the fibrous tunic. Okay. So if we move to the inner layer, so the inner layer of the eyeball, so that's the vascular tunica. Okay, vascular tunica. Vascular tunica is made of the choroid. Okay, choroid. So this is choroid. Okay, choroid and iris. Okay, iris. The third is the ciliary body. Okay, ciliary body. You can see, oh, this one, ciliary body. Ciliary body. Ciliary body is ciliary body has two parts. Okay, so the first up, ciliary body has two parts. So the first part is the ciliaris. Okay, ciliaris. We have that one. No, ciliaris. Okay. The second is the ciliary process. Okay, ciliary process. So this is the ciliary process. This is the ciliaris. Okay, ciliaris. So the ciliary process actually attached to the ciliary zonules. Okay, zonule is also called suspensory ligament. So this ligament actually links the ciliary process and the lens. Okay. So we can see the ciliary body, iris, and choroid. Actually, they make the vascular tunic. Okay, they make the vascular tunica. So actually, the choroid actually is the pigmented membrane. Okay, so this choroid can actually absorb the scattering light wave. Okay, so it can make our vision very accurate. Okay. So so if we continue move inward, so the third layer is the sensory tunic. Okay, sensory tunic. So the sensory tunica is made of two parts. Okay, one part is the retina, another part is the vitreous humor. Okay, vitreous humor. So it's this one. Okay, vitreous humor. So the vitreous humor and the retina uh, make of the sensory tunica. Okay, makes of the sens sensory tunica. Okay, so this is eyeball. Okay, so since this is eyeball, so it has eye cavity inside. Okay, so the eye cavity inside can be divided to two parts. Okay, one is the anterior segment. Okay, anterior segment. is also called anterior cavity. Okay, anterior segment is from the uh, inner layer of the cornea to the lens. Okay, to the anterior uh, border of the lens. Okay, so this is called anterior segment. Okay. No, it's from interior lens, interior layer of the cornea to the anterior border of the vitreous humors. Okay, so this is the anterior cavity. Okay, so from anterior border to of the vitreous humor to the posterior border of the vitreous humor. So that's the posterior segment. Okay, posterior segment. Now let's take a look at the anterior segment. Anterior segment. So the anterior segment can be divided to two chamber. Okay, two chamber. So we can so the two chambers are anterior chamber and posterior chamber. Anterior chamber actually is the cavity from the interior layers of the cornea to the iris. Okay, to the iris. So this is the anterior chamber. Okay, anterior chamber. So this is anterior chamber. So the posterior chamber is from the iris to the vitreous to the anterior border of the vitreous humor. So this is called the posterior chamber. Okay. So we can see. So there is only the liquid materials in the anterior chamber. However, in the posterior chamber, so we have the lens, ciliary zonules, and the ciliary process. Okay. So so the ciliary process. So this is the ciliary process. Okay, on the top of the ciliary process, so actually there is one layer of specific endothelial cells. Okay, so those cells can actually secrete the liquid material. So this is called aqueous humor. Okay, aqueous humor. So this liquid material actually can flow from the posterior chamber through the iris to the anterior chamber and then drawn to the sclerovenous sinus. Okay, this is also called the canal of the Sherman. Okay, canal of the Sherman. And then so the aqueous humor can be drained to the vein. Okay. So so we can see, so this is ciliary body. Okay, ciliary body. Ciliary body can actually attach to the scleral. Okay, so we can see the border. So the border of the attachment. So this is called. So this. So we can see the muscular column. So the muscular column is called ora serrata. Okay, ora serrata. So now let's take a look at the sensory tunica. Okay, sensory tunica. Sensory tunica is made of the retina. Okay, retina. So the retina actually retina has photoreceptor cells. Okay, so so those cells actually can send the neuron action. Okay, to form the optic nerve. Okay, optic nerve. So all the axons actually come together to form the optic nerve. So the optic nerve can can pierce through the sclera. Okay, so this part is called optic disc. Optic disc. Okay, so actually this part doesn't have any photoreceptor cells. Okay, so that means this disc actually cannot generate the vision. Okay, so that's why it's called a blind spot. Okay, blind spot. So in the center of the optic nerve, actually it contains the vessels. Okay, it contains artery and veins. Okay, so this artery and veins will send branches to provide the nutrients and oxygens to the retina. Okay, so so close to the optic discs, we can also see a dark spot. Okay, so this is called macula lutea. Okay, macula lutea. Macula lutea actually is a region that has a highly density of the photoreceptor cells. Okay, that's why this is, this small spot can generate a very precise vision. Okay, so the eyeball we can see. So the center point of the cornea is called the anterior pole. Okay, so the posterior central spot is called posterior pole. Okay, posterior pole. So this is the structure of the eyeball. Okay, structure of the eyeball. So now let's talk about the iris contraction. Okay, iris contraction. So the iris contraction, actually the iris is innervated by two nerve. Okay, by two nerve. So these are the parasympathetic nerve and parasympathetic nerve and sympathetic nerve. Okay. So so the actually so the iris so actually so the so we can see the so this is the iris. Okay, this is the iris. So the iris actually has two type of muscles. Okay, one so we can see this circle arrangement muscle. This is called so this is called a sphincter pupillae. Okay, sphincter pupillae. You can see a sphere pupillae. We can see this radiatic arrangement muscle. So this is called dilator pupillae. Dilator pupillae. Okay. Actually, so the sphincter pupillae muscle is innervated by the parasympathetic nerve. Okay. However, the dilator pupillae is innervated by the sympathetic nerve. Okay. So once the parasympathetic nerve is stimulated, so it can send the action potential to induce the contraction of the sphincter pupillae muscle. Okay. Once the sphincter pupillae muscle contracts, it can squeeze the iris, so induce the iris close together. Okay, so it can decrease. So in the central region of the iris, so this is pupil. Okay, so once the sphincter pupillae squeeze is contracted and squeezed, so it can make the iris close together to induce pupil pupil very small. Okay, pupil very small. However, once the sympathetic nerve is stimulated, so it can stimulate the dilator pupillary muscle. Okay, dilator pupillary muscle, we can see that once dilator pupillary muscle contract actually, so it can make the pupil very large. Okay, so this is called pupil dilation and constriction. Okay, so we can see the pupil dilation is induced by the sympathetic nerve. Okay, however, constriction is induced by the parasympathetic nerve. So the retina, okay, actually in clinic, so the physician can use certain devices to visualize the retina. Okay, so it's like this picture. So if the physician see this picture, actually we can see this part is the optical disc. Optical disc. Okay, optical disc is also called a blind spot. Okay, because this part doesn't have any photoreceptor cells. Okay, so so this region, the optical nerve pierces through the eyeball. Okay, since we know in the central part of the optical nerve, so there is the vessel. We can see the vessel. So the artery and the veins send the branches from the optical disc to the other region of the retina to support the oxygen and the nutrients. Okay. Here we can see a dark spot. So this is called macula lutea. Okay, macula lutea. Macula lutea has the highest density of the photoreceptors cells, so it can generate very precise vision. Okay. Actually, this whole part is the retina. Okay, retina contains the photoreceptor cells and vessels. Okay. So now let's talk about the retina. The retina is the part of sensory tunic. Okay. So the retina is made. Retina has three type of cells. Okay. So those three type of cells are the photoreceptor cells. Okay. Photoreceptor cells. So we have two type of photoreceptor cells, rounds and cones. Okay. So the second type of cells is bipolar cells. Okay, bipolar cells is like this one, bipolar. Why? So why is this cell called bipolar? Because we can see so this is cell body. So we can see the cell have two processes. Okay, two processes. That's why it's called bipolar. Okay. So the third type of the cell is the ganglion cell. Ganglion cell send the axon to make of the optical nerve. So this is optical nerve. Okay, optical nerve. So the retina, actually, the retina. So this is the basal layer of the retina. Basal layer retina actually is the pigmented layer. Okay, because this layer of cells actually contains the pigment, dark pigment. Okay, so the pigment is called melanopsia. Okay, melanopsia. So this pigment actually can absorb the scattering light wave. Okay, so the light ring. Okay, can help to make the precise vision. So now, so let's talk about the cones and the rods. Okay, so we can see this is the cones. Okay, so the cones actually is very sensitive to the bright light. Okay, it can it is responsible for the light vision and precise vision. Okay, so this is rods. Okay, rods. So the rods actually it's very sensitive to the dim light. Okay, so it is responsible for the dark vision, and dim vision. So we can see the we can see here. So several rods actually can link to just one ganglion cells. Okay. However, for the cones, so one cones actually uh, link to just one ganglion cells, because the cones is responsible for the precise vision. Okay, we can see we can see all the photoreceptor cells, bipolar cells, and ganglion cells. So they are arranged vertically. Okay. However, we can see here. So there is one cells. This cells is arranged. So this cells is arranged horizontally. Okay. So that's why this cells is called a horizon. Is called horizontal cell. Okay, horizontal cell. Horizontal cell actually we can see it link with the synapse between the photoreceptor and the bipolar cell. Okay, so the horizontal cell's function is to regulate the vision. Okay, it is actually it secretes the GABA neurotransmitters to inhibit the synapse activity between the photoreceptors and the bipolar cells. Okay, so their function is to regulate the vision. Okay, so so between bipolar and the ganglions, we also have another horizontal cell. So this is called amacrine cell. Okay, their function is also to regulate the vision. Okay. Now let's so this slides talks about the function of the rods and the cones. Okay, so we can see the rods. So the rods actually is responsible for the dim vision, dark vision. So because it is very sensitive to the dim light. Okay, dim light. So so it also responsible for the peripheral vision. Okay, because these rods actually can be found. So most of the rods actually can be found in the peripheral region of the eyeball. Okay, so it is responsible for the peripheral region. And probably we have the peripheral vision experience. Okay, so the peripheral vision, so we can see the objective. So we can see the object. So we can see the object shape and the movement. Okay. However, we cannot see the detailed characteristics of the of the object. Okay. So this is peripheral vision. For example, so you can see a person stand. So you can see patients. So you can see people standing so near you. Okay. However, so you can just only see the people's size, shape, or the moment. However, you cannot see his face. You cannot see the color of his clothes. Okay. So this is the peripheral vision. Okay. So the rounds is so the rounds cannot contribute to the color vision, cannot contribute to the precise vision. However, it is very sensitive to the optic. It's very sensitive to the to the movement vision. Okay, it can so it can also so it is also sensitive to the night vision. Okay, night vision. So since ROBS is very sensitive to the dim vision, that means several ROBS they are linked with just one ganglion cells. That means so the action potential of the rods or the information of the rods can be amplified. So if several rods feeds into just one ganglion cells, that means the information or the action potential can be amplified. Right? So rods actually contribute to the fuzzy and indistinct image. Okay. Now, second is the cones. Okay, cones is responsible. Is sensitive to the bright light and precise vision, high resolution color vision. Okay, so this is called acuity color vision. So the most of the cone cells are located in the central region of the of the retina. Okay, so that's why so the cones actually receive the highest density of the light rays. Okay, light rays. Also, one cones feed just one ganglion cells. That means so the so one cone cell just is just responsible one specific part of the image. Okay, so that's why it can generate a very high resolution and precise vision. Okay, so it can also detect the color. Okay, so especially the macula lutea has highest density of the cones. Okay, so that's why if we want to see if we want to see object very detailed, so we have to move our eyeball to let our macula lutea to just face straight to the object. Okay, and so we can see so we can see the detail characteristics of the object. Okay. So the since we have here we so in this slide retina has three layers. Okay, so the ganglion cells actually send the axon. All the axons can come together to form the optical nerve. Okay, optical nerve is like this one. So this is the ganglion cells. So the axon can form the optical nerve. So this is the so this is the optical disc. Okay, optical disc. In the center of the optic disc, so we have the vessels, arteries, and veins. Okay, arteries and veins send the branches to support the retina. Okay. So now let's talk about the anterior segment. Anterior segment. Okay. Anterior segment. So I have mentioned that so the ciliary process actually on the top of the ciliary process so there is specific endothelial cells. So these cells can secrete the aqueous humor. Okay, aqueous humor. Aqueous humor is the liquid material. So this material can flow through the pupil to the anterior chamber. Okay, anterior chamber, and then drawn to the lens through the sclerovenous sinus. Okay. So this is the part of the corneal scleral junction is called the limbus. Okay, limbus. So this is ciliary veins. It can draw the aqueous humors. Okay. So the anterior segment it consists of the anterior chamber and the posterior chamber. Anterior chamber is from the cornea to the to the pupil. Okay, so from the pupil to the anterior border of the vitreous humor. So this is the posterior chamber. Okay, posterior chamber. So this is the aqueous humor. Aqueous humor is secreted from the epithelial cells on the ciliary process. Okay, ciliary process. Ciliary process and ciliary muscles is called ciliaris. Actually, makes the ciliary body. Okay. So the cornea. Okay, cornea. So this is the cornea. Okay, this is cornea. So the cornea cornea is very specific tissue. Okay, because the cornea is cornea is transparent. Okay, cornea is transparent. So the cornea. Actually, the cornea is not just one membrane. Okay, so the cornea is tissue. So this tissue actually has 5 layers. Okay, 5 layers of 5 layers membrane. Okay, so from the outermost to the innermost. So actually, so the first layer is epithelial layer. Okay, epithelial layer. So the second layer is Bowman's membrane. Okay, so the third is a stroma layer. Okay, fourth is so is a Descemet's membrane. So the fifth is endothelium layer. Okay, so the epithelium actually is the first layer. Okay. So we can see actually the cornea is a complex tissue. Okay, it has 5 layers. So the cornea actually gets the nutrients and get the nutrients from the aqueous humor. Okay, cornea can also get the oxygen directly from the air. Okay. So this is anterior segment. So since our eye can make the vision the vision by receiving the light, so the light rays. Okay, so actually let's talk about the light. Okay, actually the light is one specific so the lights actually, so we have this scale. Okay, we can this scale. So the lights actually contains several different parts of the so it contains several different parts of the light with different so with different wavelengths. Okay, with different wavelengths. So based on the wavelengths, so we can divide the light to this 7 part. Okay, 7 part. Actually, our eyes can only see this very narrow region of the light. Okay, So this is called visible light. Okay, so except this region, all this part, and this part are the invisible lights. Okay, invisible lights. So the invisible lights includes the radio waves. Okay, and microwaves. So the infrared light. Okay, ultraviolet lights and X-rays, gamma rays. Okay. So if we zoom in the visible lights, we can see the visible lights is the lights with the wavelength from the 400 to 700 nanometer. Okay, and so we can see the 700 wavelength actually is red. Okay, the 400 wavelength is blue. Okay, in the middle of 500 actually is green. Okay, so the different wavelengths can cause different color. Okay, so now let's talk about the focusing. Okay, focusing. Um, because we know our eyes have the ciliary body. Okay, ciliary body. So the ciliary body have its specific function. Okay, the ciliary body's function is to focus and is to let the lens focus and to generate very precise vision. Okay, for example, for the distant vision. Okay, for the distant vision, that means if the object is very far from our eyeball. Okay, it's very far from our eyeball. Actually, so we can see the so if the object is very far from our eyeball, so this is a distant vision, is far vision. Okay, so in this case, actually, the sympathetic nerve is activated. Okay, activated and stimulates the and sends the action potential to the ciliary body. Okay, to the ciliary body. To the ciliary body and to the ciliary body and to cause the relax of the ciliary body. Okay, relax of the ciliary. Once the ciliary body is relaxed, so the ciliary body will become longer and thinner. Okay, thinner. So once the ciliary body is thinner, so the so the ciliary process will track the zonule. Okay, track the zonule. So we can see the zonule is actually attached to the lens. Okay, so to attract so the zonule. The zonule is also called a suspensory ligament. Okay, suspensory ligament. So the suspensory so the zonule is very tight. Okay, so very tight. So if the zonule is very tight, so it can track the lens to let the lens is very flat. Okay, here is the lens, let the lens very flat. So that's why. So it can so it can so if the lens is very flat, so it will deviate the light ray less. Okay, so it can so it will so it can generate a very precise vision for the distant object. Okay. However, for the near vision, okay, that means if the object is very close to our eyeball, such as like so the distance is lower than 20 feet, okay. So actually, in this case, so the parasympathetic nerve is activated, okay. Parasympathetic nerve is activated. So the parasympathetic nerve actually can stimulate the specific receptor in the in the ciliary body. Okay, so this receptor is muscarinic 3 receptors. So it can cause ciliary body contract. Okay, ciliary body contract. Once the ciliary body contracts, so it can cause the ciliary body very sick. Okay, very sick. So it, once the ciliary body is sick, so it can lose the zonule, the ciliary zonule. Okay, ciliary zonule can lose the ciliary zonule. So the ciliary zonule is very loose. Okay, so if the ciliary zonule is loose, so the lens will be so the lens will bulge. Okay, lens will bulge. So once the lens will bulge, it can deviate the light rays more. Okay, to generate the very precise near vision. Okay, so this is called focusing. Okay, this is called focusing. So if we cut the eyeball through this part, we can see in the central region. So this is lens. Okay, the lens actually are linked with the ciliary body through the ciliary zone. Okay. So now let's talk about the vision pathway. Okay. So if you guys have any questions, please feel free to email me. Okay, I know this is very complicated. So the vision, okay, vision. Since we have 2 eyeballs, okay, we have left eye and right eye. Okay, so obviously, left eye is responsible for the left region vision. So the right eye is responsible for the right region vision. Okay. However, we can see so these 2 vision actually have the same zone, Okay, so once the eyeball movement actually so they can focus to one point. This is called a fixation point. Okay, so that means both eyes actually look at one point. Okay, so it can generate very precise vision. So we so through the line of the anterior pole and the posterior pole, so we can divide the eyeball to 2 parts. Okay, so because this is north. Okay, this is north. So we can divide the eyeball to the so the nasal hemi-retina and lateral hemi-retina. Okay, so we can see the for example, for the left eye, okay, so the nasal light ray actually hit the lateral hemi-retina. Okay, however, the lateral light ray hit the nasal hemi-retina of the left eye. Okay, so it's same thing for the right eye. Okay, so the nasal for the right eye, so the nasal light ray hits the lateral hemi-retina of the right eye. Okay. However, the lateral lattice hits the nasal hemi-retina of the right eye. Okay, so we can see. So this is the nasal hemi-retina. Okay, so this part, in this part, uh, so the optical nerve fibers actually they are cross. So this is optical chiasm. Optical chiasm. Okay. So in the optical chiasm, okay. So the nasal optical nerve fibers actually cross to the contralateral part. Okay. So the same thing for both two eyes. Okay. For the left eyes, so the nasal part of optical nerve fibers cross to the contralateral. That means cross to the right part. Okay, right part of the optical tract. Okay. However, the lateral, so the lateral hemi-retina optical nerve fibers actually doesn't cross. Okay, so it will continue go to the ipsilateral of the midbrain. Okay, so this is the midbrain. This is midbrain. Okay, this is midbrain. So this part is called lateral. This part is called lateral geniculated nucleus. Okay, lateral geniculated body of the thalamus. Okay. However, the nasal part of the retina optical nerve fibers cross at the optical chiasm to the contralateral later geniculate body. Okay, right. So now we can see in each side of the lateral geniculate body, so it will receive the optical nerve fibers from the ipsilateral from the ipsilateral lateral retina optical nerve fiber. Okay, and contralateral nasal retina optical nerve, right? So now let's take a look at this part. Okay, this part. So this part is called this part is called suprachiasmatic nucleus. Okay, so it has another name. It's called Eddington-Westphal nucleus. Okay, now here this part is called pretectal nucleus. Pretectal nucleus. Okay, pretectal. So this is Eddington-Westphal nucleus. Okay, and then we have the third nucleus. So this is called superior superior colliculus nucleus. Okay, this one, superior colliculus. Okay, so we can see the actually. So once the optical nerve fibers reach to the lateral geniculate body. Okay, so this fibers can send the neurofibers to reach to the pretectal nucleus, okay, and then the pretectal nucleus can also send the fibers to link with the Eddington-Westphal nucleus. Okay, so the lateral geniculate bodies can send two fibers to link with both ipsilateral and contralateral of Eddington-Westphal nucleus. Okay. in the same time, so the optical nerve also sends the fibers to link with the superior colliculus body. Okay, superior colliculus body, and then so the lateral geniculate body also sends the fibers to link to reach to the occipital vision cortex. Okay, so this is called this. So we can see we have two tracks. Okay, so one track is so this track is called inferior retina fiber. So this is called the superior retina fiber. Okay, so this fibers can generate the vision. However, so the fibers link with Edinger Westphal nucleus and pretectal nucleus. So this nucleus will send the fibers to innervate the send fibers to the ciliary ganglions. Okay, and through the ciliary ganglions, then send the fibers to the ciliary. Okay, to the ciliary to induce focusing and accommodation. Okay. So now let's talk about the color blindness. Okay, color blindness. Since the cones can, the cones can respond to the different wavelengths of the light rays, can generate the color vision. Okay. However, if there is a defect on the cones, okay, so the people will have the color blindness. So typically we have three types of color blindness. Okay, so here we just talk about the first two color blindness. The first is the proton color blindness. So the proton color blindness is more like the congenital diseases. So this color blindness is induced by the dystrophy of the cones. Okay, so this is the a red green blindness. Okay, red green blindness. However, this blindness is more it's more related to the red. Okay, so because the patient with this color blindness, so they cannot see the red and the green. Okay, so they cannot see the red and green. However, this color blindness is more related to the red. Okay, so this is called because the red cones are more infected. Okay, so this is more the conjunctive so this congenital diseases. Okay, so that means the baby, once the baby is born, so the baby has this blindness. Okay, so second is Dutton color blindness. Okay, so the Dutton color blindness is also the red and green color blindness. Okay, so this patient cannot see the red and green. However, this color blindness is more related to the green. Okay, we can see here. So if we compare this to the proton color blindness, so we can see this patient can still see a little bit of red. Okay, so that means they can see the orange. Okay, they can see the orange color. So they can still see a little bit of red. So this type of color blindness is more acquired diseases, such as so probably the patient get some infections, so they have the vision and neuritis. Okay, probably the ganglion cells have probably the diseases can destroy the ganglion cells and induce vision and so the vision neuritis. Okay, so it can cause the Dilton color blindness. Okay, so the Dilton color blindness actually is more related to green. Okay. Okay, so this is today's class. Okay, I hope you guys enjoy this. We also have some other documents related to this class. For example, this is so this is so if we have the lab class, okay, so we will dissect the so the bone eyes, okay, bone eyes. So if we cut the bone eyes, actually, so this is what we see, okay. So we have the retina, okay. So this is retina, and then so we can see this is the lens, okay. This is the lens. We also can see the ciliary muscle, iris, okay, iris and the pupil, okay, pupil, and the optic nerve. So this is optic nerve, okay. So this is vitreous humors, okay, vitreous humors. So this is the retina, okay. So the actually, so the vitreous humors can push the retina close to the scleral, okay. So so even now we have the online class. We don't have the opportunity to do this experiment, to do this dissection. However, since we have this file, we have this document, so please review this, and probably you will get a question from this image. Okay, so this is eye dissection. We also have. I know some students don't have the mastering AMP access. Okay, so however, in this document, I collected some online resources for the vision, hearing, and taste. Okay, so you guys can use this for your study. Okay. Okay, this is I also have this this image. Okay, you guys can use this to figure out the structure in the eyeball. Okay, so I'm sure you guys will get this in your final exam. Okay. Okay, so this is today's class. I hope you guys enjoy this.